6.2, the beginning of factoring. So we're going to start with polynomial expressions and factor, meaning we're going to take something common out of each. So here we have the numbers 4 and 2. So we can take 2 as far as the number goes out of each. Also, we have a squared and an a. So this a is to the first power. If we have like bases, we can take the lowest power of the variable. So that's a to the first. Now when we take the 2a out of 4a squared, we're left with 2a. So what goes in parentheses is what's left after we factor out the common factors. Likewise, we divide 2a by 2a, and we get 1. So if you distributed this 2a back, you'd end up with the original problem. So our next one here is 3xy plus 6x. So the numbers are 3 and 6. So out of the 3 and the 6, we can divide both by 3. So we're going to take a 3 out because it's common to both. Each one of them has an x, so we can take an x out. When we take the 3x out of 3xy, we're left with y. And when we take a 3 out of 6x, or 3x out of 6x, we're left with 2. Again, if we distributed this back, we'd be right back to the original problem. Now here, we have a polynomial, a trinomial actually, and we have an x squared term. So we are going to put it in to 2 separate parentheses. And if we were to FOIL our result back, we'd be right back to where we started. So we know x squared is x times x. So we need 2 factors of 2 that add up to 3. So 2 times 1 is 2, and 2 plus 1 equals 3. So these are 2x and x. So that's, if we FOIL this, x times x is x squared. The outside is 1x, and the inside is 2x, which combine to make our 3x. So that's the first one factor. Notice that all the signs are positive, so these signs in parentheses will both be positive. The next one, the last term is positive, but the middle term is negative. So each one of these terms in parentheses is going to be separated by a negative. So x squared is our x times x. 6, we have to find 2 factors of 6 that add up to negative 5. So both these factors have to be negative. So negative 2, negative 3. So negative 2 times negative 3 is 6, and negative 2 plus negative 3 is 5. And we're getting off the track here. Okay. So if we were to FOIL this, we would be right back to where we started. The next one, notice that the last term is negative. When you're factoring a trinomial, it has a squared term in it. Last term is negative. One is going to be positive. One of them is going to be negative. So we need 2 factors of negative 21 that add up to negative 4. So they would be negative 7 times positive 3 is 21, and negative 7 plus 3 is negative 4. Negative 3, I'm sorry. Well, scratch that. Negative 7 and a positive 3 or negative 4 for our middle term. And again, if we were to FOIL that back, we'd end up right where we started. If you run across one that has a negative in front of the squared term, then you're going to have to factor that negative out. Remember, this is like a negative 1 here. So when you divide each term here by negative 1, h squared is positive, the positive 2h becomes negative, and the positive 63 becomes negative. Then we can factor what's inside the parentheses. So 2 factors of negative 63 that add up to negative 2 are negative 9 and a positive 7. So when you have one with a negative in front of the squared term, you want to factor that out. Okay, next, we're going to look at the greatest common factor. So here we have 2, 26, and 80 for our numbers. So we can take a 2 out of each one of these. That's where we get the 2 here. Also, we have an x in each of these terms, so we can take out the lowest power of the variable out of each. So that's where we get the 2x squared as our greatest common factor. When we divide each of these terms by our greatest common factor, which is 2x squared, excuse me, we get x squared for our first term. And then when we divide the second term by 2x squared, we get 13x, and this one by 2x squared, we get 40. So again, if you distributed that 2x squared that you took out times each of the terms in parentheses, you'd be right back to where you started. So now we can factor this, and this 2x squared just continues out in front of the parentheses. So 2 factors of 40 that add up to 13 are our 8 and 5. Multiply these, you get 40. Add them, you get 13. Okay, another thing to remember is make sure that the problem is in descending order, meaning the highest power of the variable first. So here we have a squared term to the first power and to the third power. So we want to put that in descending order, meaning that the g to the third is the highest power, then second, then first. So now that we have it in descending order, we can factor out a g. We're going to divide each of these by g. So we end up with, in parentheses, g squared minus 13g plus 36. 2 factors of 36 that combine to be negative 13 are negative 9 and negative 4. So these go in the parentheses, and we have to have both negatives so that when we multiply the negative 9 times the negative 4, we get a positive 36. The next part is x squared minus 49. No middle term. This is the difference of squares. So you're going to have x times x to get your x squared, and then the square root of 49 is 7. So you're going to have a positive 7 and a negative 7. So if you were to FOIL this back, there would be no middle term. You may see it like this, or with the number first. So again, when we factor this, we're going to have our x and x, only it's going to be in the last position in the parentheses instead of the first. And then we'll have 49, the square root of that is 7, so we're going to have 7 plus x and 7 minus x. So again, we have no middle term. Another one here, x squared plus 16x plus 64. We know that we have x times x. And then we have two factors of 64 that add up to 16, which would be 8 times 8. So you'll notice when we do that, we have two parentheses that are the same. They're both to the first power. So in Alex, they prefer you to write it this way. We're multiplying these parentheses, so we add the exponents. The 1 and the 1 make their 2. So always remember, put it in descending order. First, if it's not, then factor out the greatest common factor if you can, and then finish factoring.